Okay. So let us see the first lesson in elasticity. So a spring is 60 centimeter long. So what is the length of a spring? Length of a spring is 60 centimeter. So it is stretched by 2 centimeters. Okay. So it is stretched by this much distance. So what is the elongation produced? Elongation produced is 2 centimeters. Clear? And what is the load we have applied now? 200 grams of load. So what will be the length when a load of 500 grams will be applied? Now instead of 200 grams, how much load we are applying? We are applying a load of, so 500 kg. This is the given question. Then what will be the total elongation produced? So this x value I want to find. Okay?
500 grams.
Huh? 500 grams. 500, not kg, no, 500 grams. Okay? Now can you say how can I do this problem? Anyway. See, my spring is the same spring, no? Same. So already I said you that rod just behaves like a spring only, no? Rod also behaves like a spring only. What is the reason? Because in between two molecules, any two molecules, we can assume as if springs are present. Restoring forces will be there. So therefore rod is also behaving like a spring. Same spring. So therefore if you take the X modulus of this spring, y is equals to F into L by A into delta. This is the formula of X modulus now. Okay. Same spring. So X modulus is same. Force applied is not same. Initial length is same. Area of cross section is also same. Elongation is not same. Here, X modulus is a constant. L is a constant. Area of cross section also is a constant. So what are the variables here? So I can write F by delta L is a constant. Or I can write F is proportional to delta. Mathematically I can write like this. Clear now? So therefore if F is proportional to delta L, what I can write? I can write F1 by F2 is equals to delta L1 divided by delta L2. I want a delta L2 only now. So delta L2 is equals to delta L1 multiplied by F2 divided by F1. So delta L1 is how much? Initial elongation is how much? 2 centimeters. 2 multiplied by force. See my here, load is given in terms of mass. Actually if you want to convert this one into force, you have to multiply by G1. Because F is equal to mg. But here also G, here also G. They will get cancelled with each other, so no need of multiplying. So final force is 500, initial force is how much? 200. So therefore, how much it is? 1000. Okay. Therefore, final length will be how much? No, final length. Final initial length is how much? 60. So elongation is 5. So 60 plus 5. 65 centimeters will be the final length of the rod. That is the rest. Have you understood? So based on which logic we have done just by using X modulus. Y is equal to F into L by A into X modulus. Is it clear? Second method of doing the same problem. A formula, which formula? Half kx అనేది formula లేదు అసలు. There is no formula called half kx. Half kx square is there. See my here, he gave the question of a spring. Spring. So what is the formula for restoring force produced in a spring? Restoring force is equals to minus k into x. Do you remember this formula? So this is the formula in the case of springs. This is question of spring only. So restoring force developed in the spring is spring constant multiplied by elongation. Same spring, no? So same spring means the k value is a constant. Therefore I can write k is equals to Fr divided by x. This is a constant, no? K value is same, no? Because same spring only we are elongating 2 x. So therefore I can write Fr1 divided by x1 is equals to Fr2 divided by x2. I can write like this also. And what is Fr1? The restoring force which is produced in the spring. And restoring force is equal to the weight which we have applied. No, that's it. మీరు ఎంత ఫోర్స్ అప్లై చేస్తారో రిస్టోరింగ్ ఫోర్స్ కూడా అంతే. ఓకే, సో ఐ వాంట్ x2. సో x2 how can I calculate? x2 is equals to fr2 divided by fr1 multiplied by x2. Okay, so again I got same answer. Okay, so therefore x2 value is how much? fr2. Second restoring force is 500. Initial is 200. Initial elongation is 2. So x2 is equal to 560. Okay, so therefore what is the total length? Total length is equals to, total length only now he is asking, 60 plus 5 is equal to how much? 65 centimeters. Is it clear? So by using which concept we have done? The concept of restoring force developed in a spring. Previously we have done by using X Modulus. Okay, that's it, very simple. Okay, serious question. So calculate the percentage increase in length of a wire of diameter 2.2 mm stretched by a load of 100 kg. Are you able to understand now? So X modulus of the y is also given. Okay. So what is the formula for X modulus now? Y is equals to f into L by a into delta. This is the formula of X modulus. Okay. So therefore what he is asking, percentage increase in length. It means I am supposed to calculate delta L by L multiplied by 100. This is called as percentage increase now. What is delta L? Change in length. Yep. Original length. Change in length by original length? Fractional change. Fraction multiplied by 100? Percentage. So this is what I want to calculate. So in this formula I have delta L by L now. So calculate from this one. So therefore delta L by L is equals to f by a into X modulus. Okay. So therefore delta L by L multiplied by 100 is equals to f by a into X modulus multiplied by 100. Now just you are supposed to substitute all the values. That's all. Clear? So therefore percentage is equals to force. Force is how much? 100 kg. But it is given in mass. No? How to convert this one into force? MA, mg. Here I have to multiply by g. Clear now? So therefore mass is 100, g value is 10 divided by area of cross section. Area of cross section, how can I calculate now? Diameter is given now. So therefore pi d by 2 whole square. I can write like this. Wire will be in the form of a cylinder only. What is the shape of a wire? Cylinder. So cross section area, it will be in the shape of circle. So this one, it will be in the shape of a circle only. So what is the area of a circle? Pi r square. Or you can write pi d by 2 whole square. Clear now? Multiplied by, what is the X modulus? X modulus is 4.5 multiplied by 10 power 10. Diameter is already given now. Diameter is 2.2 mm. So diameter you can write 2.2 into 10 power minus 3 meter. Okay. Substitute all these values, whatever answer you will get, that is the answer of the percentage change in length. Answer is you should get a 0.21 percentage. 0.21%. That is my answer. Is it clear? Direct to formula, that's it. See. So question is like this. The breaking stress of steel is 8 into 10 power 9 Newton per meter square. Find the greatest length of steel wire that can hang vertically without breaking. Density of steel is E. Okay, my question is that, see for example, if I suspend one steel wire, okay, then if you take a particular cross section of a wire, this part, this cross section should bear this total weight of this what you call rod. No? So if you take this point bears the weight of which rod? Uppermost rod or bottom rod? Bottommost rod. On this point, whose weight will fall? Weight of upper rod or bottom rod? Bottom rod will fall. ఈ పాయింట్ దీన్ని బేర్ చేస్తుందా దీన్ని బేర్ చేస్తుందా? It is trying to pull this rod upwards. Are you able to understand? Are you able to understand? So continuously if I increase the length of the rod, what happens now? Continuously if I increase the length of the rod, what happens? The stress which is falling on this point, it continuously increases. Clear? For example, I can carry a luggage of 10 kg. Okay, I am holding a weight of 10 kg. If you add one more 10 kg, okay, I can bear up to some extent. సరే బ్రేక్ చేస్తాడు కదా 200 kg వెయిట్ నాకు ఇస్తే నేనేమైపోతాను. I cannot hold it. It will break down. That is the same point which is happening here. So what is the maximum length of the rod I can use so that this rod does not break down because of its own weight? We are not supplying any extra load here. I am trying to find out what is the length of the same wire which can be hanged so that wire doesn't break down because of its own weight. That own weight will break down. So what is that maximum length? I can suspend it to this horizontal. Are you able to understand? So let us see what is the data which he gave. Data is that breaking stress is given. What is meant by stress? Stress is nothing but force per unit area. So how much is that? It is equals to 8 into 10 power 9 Newton per meter square. Are you able to understand? So let the length of this wire is how much? Length of this wire is here, and it will break down at this point. Clear? Because this is the point where maximum weight of the rod will be present. For example, if you take this point will bear only this much weight. This point will bear only this much weight. This point will bear only this much weight of the rod. Okay? The weight which is below that point. But if you take this point should bear total weight of the rod. No? So definitely here breaking will happen. Here the rod will break down and it will fall to the ground. The weight of the rod will become continuously more and more. Are you able to understand? So therefore the stress, so this is the maximum stress which this steel rod can bear. Are you able to understand? Stress is nothing but force per unit area. So this is the maximum force per unit area the rod can bear. So after that the rod is going to break down. That is the meaning of this one. So therefore length I want to calculate. So what I will do, see my force is nothing but weight of the rod. So at this point where the rod is ready to break down, which force is acting? Force is nothing but weight of the rod is acting on here. So instead of force I can write energy divided by area of cross section is equals to 8 into 10 power. Okay. So send or I will do one thing. Mass can be written as density into volume. What is the formula of mass? Density into volume. Because the density is given, I am trying to do in this method. Multiplied by G multiplied by A is equals to 8 into 10 power 9. Because mass is nothing but density into volume. Okay? So density is already given 10 power 4. Volume is not. Volume how can I calculate? Density is equals to mass by volume. And volume how can I write? Area of cross section multiplied by length. What is the formula of volume of a cylinder? This is the area of cross section. 2 dimensions. Area multiplied by length of the rod will be 1. So substitute here. So therefore density into, instead of volume I can write A into L multiplied by G divided by A is equals to 8 into 10 power 9. Area and area will get cancelled. So therefore L is equals to 8 into 10 power 9 divided by rho into G. Clear now? So 8 into 10 power 9 divided by, what is the density? Density is 10 power 4. G value is 10. So calculate this one, whatever answer you get. That is the maximum length of the wire which I can suspend to a horizontal support without breaking. Okay? So if I suspend this much of weight, the rod is ready to break down. Well, break avvadaniki ready ga unda. Is it clear? So what is the answer which he gave to this one? If you do this calculation, she will get 8163. Or here G value 10 is taken now. So I can take 8 into 10 power 5. That is cancelled here. So 10 power 5, 8 into 10 power 4. It means nearly 80,000 meters. Or you can write 80 kilometers. Okay. So this rod can bear how much length? It can bear a length of 80 kilometers. అంటే 80 kilometers rod మీరు సస్పెండ్ చేసినంత వరకు అది బ్రేక్ అవుతుంది. ఆఫ్టర్ దట్ ఈవెన్ ఇఫ్ యూ హ్యాడ్ 1 centimeter of rod, it is going to break. Okay, see this question now. So two exactly similar wires of steel and copper. Similar wires means what? The length, area, cross section, breadth, everything is same. So this is one rod and this is another rod. Exactly two similar rods. Okay. Lengths are same. Area of cross section is also same. That is called as similar rods. So they are stretched by equal forces. We are applying some forces on them and we are trying to stretch them. That is the given data. Okay. So if total elongation is 1 centimeter, total elongation means elongation in this rod, steel rod as well as copper rod. So it means I can write delta L of steel plus delta L of copper, both of them is equal to 1 centimeter. That is the data which we given. Then find how much each wire will be elongated. What is the elongation reduced in each wire? It means I want to calculate delta LS. Also I want to calculate delta LC. These two I am supposed to calculate. Okay. How can I calculate? See my here I have one equation. This is equation number 1. How many unknown quantities are there? 2. Delta L steel is one unknown quantity. Delta L copper is another unknown quantity. If number of unknown quantities are 2, I require 2 equations. This rule of mathematics you should never forget. If you are supposed to calculate 2 unknown quantities, you should have 2 equations. 3 unknown quantities, 3 equations. Number of unknown quantities should be equal to number of equations. Then only you can solve the problem. Okay. Now can you say another equation from where can I get? X modulus, you can take X modulus. Okay. So X modulus of steel is nothing but F into L by A into X modulus. Similarly, X modulus of copper is also nothing but F into L by A into delta L steel multiplied by delta L copper. Okay. X modulus already given, force, equal forces are same, length is also same, area of cross section is also same. Just divide them. Okay. So X modulus of steel divided by X modulus of copper is equal to, what are the terms which get cancelled now? First of all, F get cancelled, L get cancelled, area of cross section also will get cancelled because all of them are equal. Now what are the terms which doesn't get cancelled? Delta L yes, delta LCU, but they are present in denominators too. So delta LCU divided by delta L steel. This is equal to ratio of X modulus. What is the X modulus of steel? 20 into 10 power 10. X modulus of X modulus of steel. X modulus of copper 12 into 10 power 10. So 10 power 10, 10 power 10 can cancel. So 5, 4, 5 is 4, 3, 5. Okay. So therefore, X modulus of steel divided by X modulus of copper is equal to 5 by 3. This is my second equation. Already I have one equation. How many unknown quantities here also? 2. Here also. To solve them, you will get the answer. Clear now? So how can you solve? You can do one thing, no? So X modulus of steel is how much now? It is 5 by 3 of X modulus of copper. Take this value and substitute here. Okay? Substituting in this equation. Delta L of steel 5 by 3 into X modulus of copper. Delta L steel, no this one. Mistake we have done. Okay. So I am not supposed to calculate these two now, this one I am supposed to calculate. Delta L of copper divided by delta L of steel is equal to 5. Okay. So therefore delta L of copper is how much? It is a 5 by 3 of delta L of steel. Okay. So take that value and substitute. So delta L steel is how much? Delta L steel only I will write. Then instead of delta L copper, I can write this total value now. Okay. So 5 by 3 multiplied by delta L of steel is equal to 1. Okay. So delta L of steel, if you take common, then I will get 1 plus 5 by 3 is equal to 1. Okay. So therefore delta L steel is how much? Delta L of steel is nothing but, so 3 plus 5, 5 by 8 by 3, 3 by 8. Okay. 3 by 8 is approximately 3.75 something, 0.375. Okay. So delta L of steel I got. And what is delta L of copper? Delta L of copper will be equal to 1 minus 0.75. 1 minus 0.375 is equals to 0.6. That is max. Okay? Because this value is already given, no? Delta L steel plus delta L copper is 1 over. So therefore, delta L of copper will be how much? It is 1 minus delta L of steel. Delta L of steel already we have that. Okay? Okay, simple. I will explain the meaning of this person. See here. So aluminium cube. So first of all, let us try a cube now. So this is a cube. Okay. So base of this cube is fixed. Base of this cube is fixed. Then only we can change the shape of a body. If you fix the base of this body, then only you can change the shape of the body. Clear? Now if I draw a two-dimensional figure of this body, this is how cube appears like. This is a cube. Clear? And where we will apply force? We will apply force on the topmost surface. Here we will apply the force. This is the force which is applied. Area means which area we have to take? Area means this topmost area we are supposed to consider. L means what? This length is called L. Already we discussed all these points. So that side of the wall on which we are applying force is called as L. And when you apply force on this body, what happens? It shears. Shears means what now? Topmost surface moves by a particular distance. So it moves up to this distance. So this shearing, this is called as delta L. And that is already given as delta L is how much? It is equals to 0.12 centimeter. This is the understood? So what he is asking, L value how much he gave? L value is 4 centimeter. Shearing produced is 0.12 centimeter. Okay. Now what is the question? First question, shearing strain. What is the formula for strain now? Strain is nothing but delta L by L. Delta L is how much? 0.12 divided by 4. Clear? 4 3s are 12. So therefore it is 0.0. That is the strain which is produced in this. Are you able to understand? Second person. What is the second person? Shear stress. Stress how can I calculate? Stress formula? Force per unit. Force per unit. Force is it given? Area is it given? Marela just okay. Length into length. Okay. By using S square. This is a square only. No, you can calculate it. Force is it given? No. So therefore, how can I calculate? X modulus ఎక్కడ ఉంది ఇక్కడ? That is rigidity modulus, or you can call it a shearing modulus. Clear ma? Eta value, shearing modulus is nothing but stress divided by strain over modulus of elasticity. Basic meaning stress by strain. Okay. So eta value is already given. Strain we have calculated. So can't you calculate stress? So stress how can I calculate? So Young's modulus, sorry, rigidity modulus or shearing modulus multiplied by strain. Okay. So therefore, do the calculation here. So therefore, stress is nothing but eta value is how much? 0.08 into 10 power 10 multiplied by strain. Strain is 0.0. To do this calculation, you will get stress reduced in this one. And the answer is how much? 6.24 into 10 power 7. So 6.24 into 10 power 7. So that is the stress which is produced. Clear? So stress units will be Newton per meter. Third question. Which is the third question? Shearing force. Shearing force, how can I calculate? It means F value, how can I calculate? F value. Eta is equals to
F by
F into L by A into delta. So therefore eta is equals to F into L by A into delta. All values are already given. So just calculate F value, that is matched. Okay. Eta is given, L is given, area is also given, length delta L also given. Okay. So here this is a cube, no? Cube means this area also will be L into L. Okay. This topmost area will be L into L only because it is a cube. So definitely you can do this calculation. So therefore, here instead of A, what I can write, eta is equals to F into L divided by, instead of A, I can write L into L now, multiplied by delta. One L and another L get cancelled. So actually I am now calculating force. So eta into L into delta. That's it. Eta value 2.08 into 10 power 10. Length is how much now? 4 centimeter. So 4 into 10 power minus 2 meter multiplied by change in length is how much? 0.012 into 10 power minus. So do this total calculation, you will get the force which is applied. Okay. Force is how much? 9.98 into 10 power 4. That is nice. See by here, values are given in centimeters, so I am converting into meters by multiplying with 10 power minus 2. Okay? 1 centimeter is equals to 10 power minus 2 meter. Simple. So calculate the increase in energy of a brass bar of length 0.2 meters and cross sectional area 1 centimeter square when compressed with a force of 49 Newton. Okay. With how much force we are compressing this rod bar? We are compressing with a force of 49 newtons. Okay. Then what is the increase in energy? First of all, why energy increases now? Asal energy endu perugutundi?
Contraction force and compression of molecules దగ్గర
చెప్పండి. నేననే కదా ఈ క్లాస్ లో అప్లై చేస్తున్నాం కాబట్టి నేను మూడో సైడ్ అప్లై చేస్తాను కదా. See, here to compress this rod we have to do some work. To compress this rod we have to do some work. The work which you have done, it converts into energy of the rod. మీరు చేసిన వర్కే రాడ్ యొక్క పొటెన్షియల్ ఎనర్జీగా ఆల్రెడీ డిస్కస్ చేసుకున్నాము. లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ అకార్డింగ్ టు దట్ energy cannot be created, energy cannot be destroyed. If energy is increasing, it means we are doing some work. So the work which you are doing, it converts into energy of the rod. So therefore, work done converts into what? Work done converts into potential energy, or you can call it as elastic energy inside the rod. Okay? And what is the formula for energy stored? See the formula? Another formula?
Stress squared by
Inko formula? Another formula?
strain squared by
Another formula? Energy stored is equals to half into F into delta L. This formula is also there. Clear now? Half into F into small l. Yesterday only we studied now. Small l is nothing but elongation produced or compression produced in the rod. Are you able to understand? So, but here compression is it given? Delta L is it given? No. Then how can I do it? But delta L I can find in X Modulus. What is the formula for X Modulus? F into L by A into delta L. So therefore from this one delta L is how much? F into L by A into X Modulus. Clear? So take this value and substitute here. So therefore half into F into, instead of delta L I can write F into L divided by A into X Modulus. Clear? So therefore what is my formula for energy stored? So half F square L divided by A into X Modulus. So substitute all the values, that is my required answer. Okay? All values are given now. Force is how much? 49 Newton. Initial length of the rod is how much? 0.2 meter. Area of cross section is how much? 1 centimeter square. Okay? So area of cross section is equal to 1 centimeter square. I can write it as 1 into 10.4 meters square. That is in CGS system now. Centimeter square is in CGS system, convert it into SI system. Okay? Delta X modulus. X modulus is already given. Substitute all the values. And the answer which I will get is 2.24 into 10 power minus 5. 2.4 into 10 power minus 5 joules. That is the amount of energy stored in the sigma. So a 40 kg boy whose leg bones are 4 centimeters square in area and 50 centimeter long. Okay, his leg bones will be the thigh bones. So he is discussing about the thigh bones now. They are 4 centimeters square in area and length is 50 centimeter long. And this boy, he is jumping from a height of 2 meters, okay, without breaking his leg bones. So if the bones can withstand a stress of 0.9 into 10 power 8 Newton per meter square, calculate the X modulus of the bone. That is the question. Let us see what is happening here. See now. So this person, he is jumping from what height? He is jumping from a height of 2 meters. Okay. So this is ground. From ground he is at a height of 2 meters. When he is at a height of 2 meters, he is having some potential energy. When he is at a height of 2 meters, how much potential energy this person has? So potential energy formula mgh only one. This is the equation for potential energy. And when he jumps from this height to the ground, his potential energy converts into kinetic energy. His potential energy converts into which kind of energy? Kinetic energy. And this total potential energy will be converted into elastic potential energy of the bones. Okay? So, if he jumps from this height, this energy should be converted into another form. No? And what is the form? This form, kinetic energy. And this kinetic energy also becomes zero, no, when he falls on the ground. When he is about to touch the ground, this person has this much kinetic energy. When he lands on the ground, total kinetic energy was converted into some another form. What is that form? Bones will get compressed, no? Because he is landing, this total initial energy converts into energy stored in the bones. It means bones will slightly compress, temporarily. Temporarily his bones will compress. Now bones are compressing without breaking. If they compress by greater value, bones will break down. But compression is very small, so that this total energy is converted into energy stored in the bones. Are you able to understand how we are applying law of conservation of energy? One form of energy is converted into another form of energy. So therefore, what is the data which he gave? Okay. So Young's modulus of the bone he gave, and area is given, length is also given, okay, no? Height is given 2 mm, stress is given, Young's modulus we are supposed to calculate. Okay. Therefore, what I can write here, I can write mgh, total initial energy of the person. It is converting into half into stress into strain multiplied by volume also and multiplied by 2 also. Can you say why I have written 2? First of all, can you say what is half into? Stress into strain into volume? Half into stress into strain will become energy per unit volume. But I want total energy. So half into stress into strain into volume. Why I am multiplying by 2? Because 2 bones are there. No? What person has 2 bones? No, Mudasir can know Are 2 bones. Are you able to understand? So this total energy is distributed in half in one bone, half in another. Are you able to understand? So I am multiplying by 2. But the problem is that here only stress and Young's modulus are given. Okay. So therefore, strain, how can I write? Strain can be written as Young's modulus multiplied by. So Young's modulus is equal to stress by strain, no? So therefore, instead of a strain, what I can write? Instead of a strain, I can write a stress divided by Young's modulus. So substitute in this formula. So therefore, already we have an equation on this one previously. So half into stress multiplied by strain value is how much? Stress divided by Young's modulus multiplied by volume multiplied by 2. Okay. What is calculating? Asking us to calculate Young's modulus. So take Young's modulus to this side. Young's modulus is equal to half into stress square. Stress square divided by Young's modulus multiplied by mgh multiplied by volume multiplied by that's it. Is it clear? All the values are already given. X modulus already I have taken from this side. Okay. So stress is given 0.9 into 10 power 8. Volume means which volume? Volume of the bone. Volume of the bone formula? Area of cross section multiplied by length. Clear now? mgh, mass of the person 40 kg, g value 10, height is 2 meters. All values are given. So just substitute, that is my answer. Clear now? So therefore here volume of the bone is how much? Area of cross section multiplied by length. Area of cross section is 4 centimeters long. So 4 into 10 power minus 4 multiplied by length is 50 centimeter or 0.5 meters. So substitute these values here. Then the final answer which you should get is 2.025 into 10 power 9. Okay. So 2.025 into 10 power 9 Newton per meter square. So that is the X modulus of the bone. Have you understood? Okay, man? Already we have written all these formulae previously, no? So just we are using those formulas. Right.